Thanks for hopping into Keep It Simple about SRE practices or site reliability engineering. SRE as such is a next generation evolution in the IT operations practice. This was introduced and coined by Google. Though Google has introduced this, every company has their own way to implement this. The underlying principle or the foundation of SRE practices is to embrace risk. What that means is managing and controlling the faults and failures within the IT ecosystem effectively so that the end users and the customer experience and the business is not impacted because of any failures and faults, right? So the ultimate goal why this has to be done is because every company, to keep up with the business initiatives, they have to continuously develop and releases new codes into the production, right? So to balance the new development code development and releases with the reliability is the ultimate goal. What is why SRE has to be implemented. There are important few tenets of the site reliability engineering practices. One of the foremost cornerstone of SRE is the observability, and observability is like a radar that continuously scans our IT ecosystem continuously and proactively alerts us, notifies us about any issues or incidents that we have to preemptively take action so that our customer experience or the business is not impacted, right? So the way SRE focuses on observability is through the SLIs and SLOs. What actually that means is SLIs is service level indicators and SLOs are service level objectives. In simple terms, SLIs are like your metrics and SLOs are your targets, which is, for instance, CPU is the CPU usage is the matrix, whereas it has to be always less than 90% is your target SLO. And the other important factor how in SRE principle is the error budget. The way it has to be continuously monitored, and at some point if the error budget is beyond the customer expectation, then that's the point where we have to proactively start taking action to control the reliability of all the overall IT systems. The error budget can also be mentioned as reliability burn rate, right? So for instance, if in the same example, if our error budget is to keep up always 90% or less CPU usage in a month, then there we have a 10% of room that we can always go beyond that 90%, and that the 10% has to be controlled in the error budget. There's another concept of golden signals that's very important in SRE practices, which is about there is like hundreds of metrics that can be configured, but it is important to configure only that matters to our end users, and this is so that we can stay focused and there is not much alert fatigue. There is not much false alerts that is being ingested into the IT environment. And the golden signals are just 4 or 5 important signals that are very important to our customers. This is there's a mnemonic code to remember that, which is Tesla, right? So, which is throughput, error rate, saturation rate, latencies, and availability. These are the 4 or 5 important signals that we can configure in our SRE dashboard, and we have to just focus on that to get the complete 360-degree visibility of our customer experience. The other important aspect about observability is pillars of different observabilities are logging, tracing, and metrics, right? So these are the 3 important aspects to have a 360-degree visibility of our entire IT ecosystem. And this is where the important tools like Dynatrace, Datadog, New Relic will come in play. And the next important aspect about site reliability engineering is automation, right? So automation is one of the important principle of SRE, and in context to SRE, automation means identifying all those opportunities which are manually presently done or toils and automate them as much as possible for an effective and efficient IT operations or SRE practice. The way we can do this is we can just start baselining our mean time to recover, which is like, let's say if there is an incident happening in production, and how quickly can we recover or bounce back from that situation is the mean time to recover. And if there is a lot of, if the mean time to recover is looking late longer, then obviously it's going to impact our error budget or SLOs, and that's an opportunity for us to see how we can automate that. And this is where SRE practices will come in play, using tools like Terraform, Ansible, bash scripts. All of these scripts has to be utilized to see how we can automate all of this toils to be more effective as an SRE team. And if we don't have a baseline, the other important aspect of identifying the toil opportunities, also learning from the failures, is by chaos engineering. Chaos engineering is a very important principle in site reliability engineering too. And the way we have to do chaos engineering is by injecting faults and failures in a controlled way in a production environment and non-production environment, and to measure and see how we can, what is our mean time to recover looking like, and learn from that and see how we can automate those practices and find those weakest link in our overall IT ecosystem for a better mean time to recover and better SRE practice as a whole. The whole idea here is to stay as much as resilient as possible. The final and most important thing for a successful SRE practice in any company is the cultural shift, right? So this is going to be very important for us to succeed as a team, because SRE is not about just one team doing everything. It's about the whole organization doing it together, right? So embedding reliability in SDLC is an important aspect, right? So where it's about observability is an important aspect which can be done. We can manage and control the faults and failures for effective user experience, but we have to start thinking about proactively how we can ingest the reliability practice within all phases of software development lifecycle. This is where it starts from starting from the architectural review and design phase. How can we build a fault tolerant system which is highly available and highly resilient, where redundant systems to recover from any faults or failures in production. And we have to think about this in development phase also, starting from PI planning phase or sprint planning phase. We need to have a focused SRE specific activities that needs to be integrated for our developers to make sure we have the right observability in place, we have the right caching in place, and the QA team should be having the continuous testing practices as early as possible in the life cycle, so that all those issues are addressed before even going into the later part of the branching and merging strategies, right? So shift left testing and DevSecOps is an important aspect of site reliability engineering also, to make sure that all those security related vulnerabilities are addressed as early as in the life cycle, including other non-functional testing like performance testing, compatibility testing. Everything is covered at the feature branch level itself before it is merged into the main branches. One of the important aspect is, irrespective of all these things that we are doing, failures are inevitable. It's going to happen in our production systems. So we have to have a practice where we are embracing failures and learning from that process continuously. That's where blameless retrospective will come, and the SRE team has to drive this for a very healthy culture within any organization from a reliability point of view. So once the incident occurs, the goal is to make sure we recover that incident effectively. And once that process is done, we have to have a blameless incident analysis or root cause analysis retrospective session that we have to have with the engineering team to see how effectively can we eliminate and avoid those kind of issues from future occurrences. And over a period of time, once we have implemented, the way we can see how we are progressing towards this direction in the SRE transition is by measuring important metrics like mean time between failures, which is an important aspect of site reliability engineering, and mean time to detect, which is an important aspect of how mature our observability practices, and mean time to recover, which will tell us how effective our automation is. All this together will really help us build a very effective and efficient SRE practice in any organization that can lead us in a very successful pathway. Thank you so much.